Good morning. Baraka, your hand was up. If you can hear me, please respond. Good morning. Anyone who can hear me? Yes. I hope you can hear me. So we are going to revise paper 1. The other paper 2, we did not finish section A, but you'll get the marking scheme from your various class groups. So today I was advised to revise paper 1. So again, I'll start with section B. I have shared the screen. I hope you can see it. Walter, can you see the screen? Someone to respond? Yes, G. You can unmute yourself. Can you see it? Yes?
Yes. Yes, you can see.
Okay, so we can start. So we're given a solid cube made up of a hemispherical bottom, cylindrical middle, and a conical top. We're given the height of the cylinder to be 14 and that of the cone to be 5 meters. Then the common radius is 2.1. So we are to calculate the slant height. Find the slant height of the cone. Let's try it out. How do we find the slant height of the cone? Yes, how do you find the slant height of the cone? Anyone? Slant height of the cone. How do you normally find the slant height of a cone? So for the cone, we have the height is 5 and we have its radius is 2.1. So how do you find the slant height? Yes, Victor, unmute yourself. Victor?
Use the Pythagoras theorem.
You use the Pythagoras theorem. Good. So let's use the Pythagoras theorem and get the height of the cone. Trevor? Trevor, you can unmute yourself. Melvin?
So you will take 5 squared plus 2.1 squared. Then you square root to get 5.423.
Good. So we just use Pythagoras theorem. That is the base squared plus the height squared, and then we square root to get the slant height. So the slant height is 5 point. So we've been told to give to 2 decimal places. So to 2 decimal places, you'll get 5.42. If the question was not specific, then you can give your answer to 4 significant figures if you must round off. Then part B, find the total surface area of the solid, correct to 4 significant figures. How many surfaces are there in that solid? How many surfaces? Yes, Emmanuel. Unmute yourself. Emmanuel, you can answer. Anyone else? How do you find the surface area of the solid? The solid is in the shape of a pencil. So we have a hemispherical bottom, a cylindrical height, and then we have the top is conical. So how do you find the surface area of the solid? Yes, Melvin. Unmute yourself.
The surface area of the cylinder, the hemisphere, and the conical top, which will be pi r squared plus pi r h
Which will be?
plus
Repeat the formula.
surface area of the hemispherical bottom will be 2 pi r squared
2 pi r squared, yes.
plus the surface area of the cylinder, which is pi r squared plus pi dh.
The surface area of the cylinder.
Yes.
Yes. So for the cylinder will be pi r squared h. For the cylinder, 2 pi r squared h. That is 2 pi r. Just continue. Then the conical part. 2. Okay, so we have three surfaces: the hemisphere, the cylindrical part, and then the conical part. So for the hemisphere is 2 pi r squared. And then for the cylindrical part is 2 pi r h or pi dh. And then for the conical part, we only have the curved surface part of the cone, so pi r l. So let's work it out and find the surface area. Get the three areas and then add. You can share your answers once you've gotten the surface area. Anyone who has gotten the surface area? Share your answers. Yes, anyone? Nani ameshapata? Do you have the surface area? Nani amepata? Or you can share your answers partly. Who has gotten the area of the hemispherical part? Yes, Melvin? Melvin?
The area of the hemispherical part is 27.72.
27.72, that's correct. Anyone with the area of the cylindrical part? Anyone who has found the area of the cylindrical part? The curved surface of a cylinder. That is 2 pi RH or pi DH. If you work out, what do you get? Yes, Melvin. Melvin, you can unmute yourself.
The surface area of the cone is 46.86.
The cone,
Yes.
pi RL. You got what? 46 point?
86.
0.86. You used which height?
Oh. Okay. Oh, 33.
You got 33.
Yes.
Okay. Well, I'm getting 35.77. 772. We're using pi 22/7. R is 2.1 and L is 5.2, the one we got in part A of the question. So if you work out, you're getting 35.772. And then the cylindrical part, 2 pi RH. Anyone with the answer? Yes, Emmanuel. Emmanuel amepotea. Anyone else? The cylindrical part. The radius is 2.1. Yes, Brian. Unmute yourself.
184.8.
184.8. Good. Then now we add the 3. 184.8 plus 35.772 plus 27.72. What do we get? Brian, you can give us the sum.
248.3.
248.3. Good. So that's the surface area of the solid. Then we go to the volume of the solid. The next part is the volume of the solid. So the solid is in the shape of a pencil. So the volume, we have 3 parts. You can get the volume of the cone, add it to the volume of the cylinder, and then the volume of the hemisphere. So someone to work out the volume of the cone, another one to work out the volume of the cylinder, and someone else the hemisphere. Then you share the answers. Yes, Hugo, unmute yourself. Unmute yourself, Hugo. You can unmute yourself. Hugo. Okay, maybe amepotea. Anyone else who has found any of the 3? Volume of the hemisphere, the cone, or the cylindrical part? Hugo, your hand is up. You can unmute yourself and answer. Anyone else? Volume of the cone? You people are not responding. I hope you can hear me. The volume of the cone. Nani amepata volume of the conical part? Volume of a cone is a third base area times height. Yes, APPS?
23.1.
23.1, correct. Good, Brian. Which one do you have?
I have of the cylinder and of the hemisphere, the enemy hemisphere. Of the cylinder, I have 194.04, and of the hemisphere I have 19.404.
Good. Correct. Then we add the 3. So if we add the 3, what do we get? Yes, Msili.
236.544.
To 36.544. Good. Then you are told to the nearest meter. So to the nearest meter, we give to the nearest whole number, which will be what?
237.
Good. Any question? Any question? Okay, let's go to the next question. No. So the next question is we're given is a question of a straight line. So given the equation of a straight line, L1 is given by 6x plus 3y minus 12 is equals to 0. Another line L2 is perpendicular to L1 at m, 13. L2 also passes through K, which is 3, 5. Find the value of m. So how do we get the value of m? Someone to guide us through. Someone to try. Yes, Melvin. You can unmute yourself.
So you will first change the equation of L1 in the form of y is equals to mx plus c. Then you will get its gradient. After that, you will use the formula m1 times m2 is equals to -1 because L2 is perpendicular to L1. Then using the new gradient that you'll find using that formula, you will say y minus 13 over x minus m is equals to that gradient, then you find m.
Good. So let's try it out. Find the gradient of L2 from L1. And then we can use that gradient to find the value of m. So if we write L1 in the form y is equals to mx plus c, what equation do we get? L1 in the form y is equals to mx plus c. Yes, Hugo. Unmute yourself. Hugo, you can unmute yourself. I think he's having problems. Joseph? Yes, Joseph.
Y equals to 2x plus 4.
2x plus 4.
Yeah.
Positive. Positive. They're all positive.
Yes. Oh, no. Y equals to negative 2x plus 4.
Negative 2x plus 4. Good. So the gradient is negative 2. So what is the gradient of L2? Gradient of L2? Yes, Hugo. Unmute yourself. Okay, the other one is APPS. Unmute yourself. What is the gradient of L2? Huyu ni Alan. Alan, unmute yourself.
That would be positive a half.
Positive a half, good. Now that we have the gradient of L2 as positive a half, and we have a point K, 3,5. Remember, L2 is also passing through M, 13. So using the gradient and the 2 points, what is the value of M? Yes, Tom? Tom, you can unmute yourself. Amepotea APPS.
19.
M is 19. M is 19. Good. Anyone with a question? Nani hajapata 19? Nani hajaelewa that first part of the question? Yes, Mia? Ask. Unmute yourself. Mia, you can unmute yourself. Mia, ongei. Okay. Malo? Malo, unmute yourself.
I got M as 17.
M as 17. Okay, so let me just take you through so that we see if you're getting 17. So you have M2 as a half, isn't it? Malo amepotea tena. Malo, unmute yourself.
Yes.
You have M2 as a half, isn't it? Positive a half.
Yes.
Yeah. Then now we are using point K, 3,5, and this point M, 13. Using the 2 points, we are doing change in Y over change in X, and then we equate it to a half.
Yes.
So change in Y will be 13 minus 5 divided by change in X, M minus 3 is equals to a half, and then we cross multiply.
Yes.
Are you together?
Yes.
So 13 minus 5 is what? Is 8.
Negative 8.
Positive 8. 8 times 2, you'll get 16. And then the
Yes.
other side, you'll get M minus 3.
Yes.
So if you take 3 to the side of 16, you get M as
19.
19. So,
Thank you.
welcome. Then, any other question? No question. So let's go to the second part, Roman 2. Roman 2, find the equation of L2 in the form AX. There's a question from Tom. Just a minute. Tom, you can unmute yourself. Unmute yourself. Tom amepotea, so let's go to the next question. APPS, do you have a question?
Please pardon that formula that you have used.
The one for M?
Yeah,
Okay, I have just
one
used... Okay, I've understood the question. We found M as positive a half. That is the gradient of the second line, positive a half. Then that line L2 is passing through K, and it is also passing through M, 13, since that is the meeting point. So it is passing through M, 13. So we have 2 points on the line, and we have the gradient. So we just use the 2 points to find the gradient. change in y over change in x, and then equate to a half, which is the gradient. Then from there, we cross multiply and make m the subject. Because
Oh. Mm.
okay, so the second part of the question, APPS, your mic is still on. Okay, sawa. So the second part of the question, you have to find the equation of L2 in the form ax plus by plus c is equals to 0, where a, b, and c are integers. So we know the gradient is a half, and we have a point. We actually have 2 points on the line. Let's find the equation of the line. Yes, Barastom, unmute yourself.
The equation is y is equals to a half x plus 7 over 2.
Y is equals to a half x plus 7 over 2. That is in the form y is equals to mx plus c, isn't it? Then now, we've been told the form in which to leave our answer. So leave your answer in the form ax plus by plus c. Yes, Francis? Francis, unmute yourself.
I got the answer 2y minus x minus 7 is equals to 0.
2y minus x minus 7 is equals to 0. Good. That's correct. So if you're told to leave in the form ax plus by plus c is equals to 0, once you find your equation in the form y is equals to mx plus c, make sure you rearrange in this form. And the question is also specific that a, b, and c must be integers. So they can't be fraction. They must be whole numbers. They must be whole numbers. The coefficients of x, b, and b, and also c. Sometimes the question just says you leave it in that form where a, b, and c are constants. So constants can be fractions. So you don't have to make them whole numbers. But if it's integers, they must be whole numbers. Any question? Any question? No question. So I will ask a question. Suppose, okay, there's a question. Yes, Alan. Unmute yourself.
Can you pardon the answer?
The answer is 2y minus x minus 7 is equals to 0.
Oh, okay, thanks.
You're welcome. Any other question? No question. So I suppose the question was, we find the equation of L2, leaving your answer in double intercept form. Suppose you are asked to find the equation of L2, leaving your answer in double intercept form. What would we do? Double intercept form, tungefanya nini? Anyone with an idea? Yes, suppose you were to leave our answer in double intercept form. What would we do? Yes, APPS, you can unmute yourself.
You first find the x-intercept and the y-intercept.
Good. And then?
And then you put the answer like x over the x-intercept plus y over the y-intercept is equals to 1.
Good. So you find the x-intercepts and the x-intercept and the y-intercept. Then you put your answer as x over x-intercept plus y over y-intercept is equals to 1. Mwaniki, you have a question? Unmute yourself.
Hi.
Yeah, hi.
I was asking if you could write it so that we can see.
The equation.
Yeah,
Do
how
you-
you are going to solve the double intercept.
Okay, I'll just take you through. So just write. You can write. Since if I don't have I can't show it. See now whiteboard. So I'll just take you through the question. Sawa. Mwaniki, I want your mic to be on.
Sawa.
Yeah. So I've said, first of all, find the equation of the line. We found the equation of the line. You can find it in the form y is equals to mx plus c or any other form. So we have found it as what? We found the equation as 2y minus x minus 7 is equals to 0. Sindio? Mwaniki, your mic should be on.
Yes.
Yeah, now we find the x-intercept. Find the x-intercept. At x-intercept, y is 0. So where there is y, put 0 and then make x the subject. What is the x-intercept?
A minute. 7.
X-intercept is 7. Then also find the y-intercept. At y-intercept, x is 0. So put 0 where there is x and make y the subject.
3.5.
3.5. You can write it as 3.5, isn't it? 3.5. So now once you find the x-intercept and the y-intercept, the formula for double intercept form is usually x over a plus y over b is equals to 1. X over a plus y over b is equals to 1, where a is the x-intercept and b is the y-intercept. So since we already have the x-intercept and the y-intercept, we'll just write x over,
I'm listening.
yeah. Are you together?
Yes.
So just write your answer as x over the x-intercept, which is 7, plus y over the y-intercept, which is 3.5, is equals to 1. X over 7 plus y over 3.5 is equals to 1. Then you leave it like that. You don't simplify. Go sawa?
Kwa sawa.
Aya. So there's a question here. Someone is asking if the x-intercept is positive 7 or negative 7. So from 2y will be 0. So negative x minus 7 is equals to 0. It will be negative 7, not positive 7. Negative x. So the x-intercept is negative 7, not positive 7. So when you're writing it as x over the x-intercept, you can write negative x over 7 plus y over 3.5 is equals to 1. Now, any other question? No question. So let's go to part B. So part B, that's part B of the question. Part B, the equation of the base of an isosceles triangle ABC is y is equals to negative 2. And the equation of side BC is y is equals to y plus 2x is equals to 6. If points A and C are negative 6, negative 2 and negative 1, 6, respectively, find the coordinates of B. So you can just draw the triangle, put the coordinates that you are given and the equations that you are given. Then we can now answer the question. Draw the triangle, put the coordinates, and then let's answer the question. I hope tumechora. So now if you want the coordinates of B, how do we find the coordinates of B? Anyone with an idea? How do you find the coordinates of B? Point B is the point of intersection of which lines? Yes, APPS.
You do the simultaneous equation of the equation of side BC and AB. And the
Good.
equation
Mm-hmm.
the equation of line BC is the same as that one of AC.
The equation
Yeah.
of
It's an
BC. Yeah, we are given the equation. The equations might not be the same, only the sides are equal in length. But we are given the equation of BC, and we also know the equation of line AB. So if you've drawn the triangle, B is the point of intersection of lines AB and BC. So if you want to find the point of intersection of two lines, we solve the two equations of the lines simultaneously. So let me just share the work. Are you able to see the screen for the marking scheme? Let me see if it's there. Aya. Msili, you can unmute yourself if you have a question. Okay, he's not responding. So from the triangle that you have drawn, you have the coordinates and then you have, so your point B is on line AB. And we've been given that the equation of line AB is y is equals to -2. So it means that every y coordinate of any point on line AB is -2. So the coordinates of B is x comma -2. X, we don't know the value of x, but the y coordinate we know is -2. Since the line is an horizontal line whose equation is y is -2. Then point B is the point of intersection of line BC and line AB. So for you to find the coordinates of the point of intersection of two lines, you solve the equations of the two lines simultaneously. So since we know the equation of line AB is y is equals to -2, we are going to substitute -2 into the equation of line BC, which is y plus 2x is equals to 6, so that we can find the value of x. So where there is y in BC, we substitute -2 and then solve. So we are getting our x to be 4. So the coordinates of B will be 4, -2. Any question? Yes, Jose, unmute yourself.
My question is, how do you know that B is the point of intersection while you are told that AB is the baseline?
So if you draw the triangle, so measure a triangle.
Yes.
Then line BC and line AB, they are meeting at which point?
Line?
BC and line AB.
At B.
At B. That's why I've said B is the point of intersection of BC and AB.
Okay.
Yeah. Any other question? Any other question? Okay, no question. So the next part was to find the equation of AC. Find the equation of side AC. So for you to find the equation of a line, you need the gradient and a point. So AC, we have 2 points. point A and point C. We know the coordinates of both A and C. So using A and C, find the gradient. What is the gradient using A and C? What's the gradient? Nani amepata? Yes, Hugo? Unmute yourself. Hugo is unable to unmute himself. Anyone else? Yes, Hugo?
8/5.
8/5. Good. 8/5 is the gradient. Then using that gradient and one of the
8/5.
points, find the equation of the line. Yes, John?
5y is equals to 8x plus 38.
5y is equals to 8x plus 38. Good. Any question? Anyone with a question? No question. Kuna swali kwa equation of a straight line. Any question? Yes, Jack. Unmute yourself.
Sir, I was requesting that you could show us the marking scheme one last time.
Off?
I was requesting that you show us the marking scheme one last time.
For this question?
Yes.
Okay, there it is.
Thank you. Okay, thank you, Cha.
Okay, so let's go to the next question. If your mic is on, you can mute it. Nani mic yake iko on? Someone's mic is on. Let me see, ni nani huyu? Okay. So let's go to the next question. Anyone with a question kwa equation of a straight line? Yes, Francis, unmute yourself.
Excuse me, sir.
Yeah.
I'm asking a question about getting the coordinates of B.
Mm-hmm.
We were given the equation BC.
Yeah. Mm-hmm.
And we already know the y.
Mm-hmm.
The y is going to be -2.
Yes.
Why on getting the gradient before you on using the gradient of the line to get the, like, you construct like an equation like, let's say -6 minus b over 1 minus 4 is equal to -2, which is the gradient. Why can't we get the x of b?
You can still get x by using that formula.
Oh,
So
but on my
we
side,
know,
I'm getting the answer.
okay, let me just take you through. Our gradient BC, if you write the equation, is supposed to be y is equals to -2x plus 6, isn't it?
Yeah.
So our gradient is -2.
Mm-hmm.
Then now we can find the change in y over change in x. So change in y is 6 minus -2. So that will be 8, isn't it?
Yes.
That will be 8 over -1 minus x. -1 minus x is equals to -2.
Mm-hmm.
Then we just cross multiply. So it will be 8 is equals to -2 into -1 minus x. Are you together?
Yes.
So tutapata nini? 8 is equals to -2 times -1. That will be Is it positive 2? Positive 2? Itakuwa positive 2 plus 2x. Are you together, Francis? Francis amepotea. Francis, are you together? Francis. Amepotea. So Francis, you can just find the gradient of BC from the equation of the line and then use the 2 points to find change in y over change in x and then make x the subject. Oh, there's someone anasema ati gradient ni 8 over 7, not 8 over 5. Okay, let me look at the equation. So the gradient is what? Change in y over change in x. Our points are -6, -2 and -1, 6. So 6 minus -2, that will be +8. And then -1 minus -6, that will be -1 plus 6. So it will be 8 over 5. 8 over 5. Any other question? Any other question? No question. Okay, we can move to the next question. Number 19. So number 19, we are given the what? The equation of a curve. Then find the gradient function of the curve. Find the gradient function. Let's find the gradient function. Yes, APPS. Unmute yourself.
X squared minus 2x minus 3.
X squared minus 2x minus 3. Good.
Yes.
So dy dx is x squared minus 2, x squared plus 2x minus, is it 2x? Yeah, plus 2x minus 3. And then determine the turning points on the curve. Turning points occur when what? Turning points occur when? Yes, Steve. Unmute yourself.
They occur when the gradient is equals to 0.
Good. They occur when the gradient is equals to 0. So let's take dy dx and equate it to 0 and then get the turning points.
No.
If you have the turning points, you can share. Yes, Ernest. Ernest, unmute yourself.
-3 and 11.
Yes.
1 and 11, the first point. The second point is -3 and 11.
-3 and 11. -3, 11. You're giving it
Yes.
in coordinate form. And the first one is what?
1 and 11. 1 comma 11.
Is it 1 comma 11? If you substitute 1 back to the equation of y, do you get 11?
Oh, a third, sorry.
A third, good. So it is 1 comma a third and negative 3 comma 11. Good.
Yes.
Any question? Nani hajapata? Okay, I believe we all got. Yes, Jeff, unmute yourself. Jeff, unmute yourself.
I'm asking, how do you get the turning points? Yes, I've equated to 0 and gotten the x as 3 and negative 1. I don't know how it's gotten negative 3 and 1.
Okay, let me just take you through. Oops, you okay, mic off. So your equation was x squared plus 2x minus 3 is equals to 0. Isn't it? Yeah. Yeah, so then we are solving. We are looking for two numbers that if you multiply, you get negative 3. If you add, you get positive 2.
No, pengine
Are the numbers?
Okay, setting ni mbaya.
Which are the numbers? If your mic is on,
Come
apart
again?
from Jeff, you can mute it. Let me see. Let me mute someone up. Yeah, so okay, so Jeff, I was saying
Yes.
we have our equation was x squared plus 2x minus 3 is equals to 0, isn't it?
Yes.
I'm solving by factorization. So you get two numbers that if you multiply, the product is negative 3, the sum is 2. So
Yes.
the factors will be
3 and 1.
will be negative 3 and negative 1 and positive 3. Isn't
Yes.
it? Because negative 1 times 3 is negative 3, and then if you add, you get positive 2. So if you write back if you use the factors, we'll have x minus 1, x minus 1x, and then plus what? So we have x squared minus x plus 3x minus minus 3, isn't it?
Yes.
Then if you group the first two and also group the last two, in the first bracket, x is common, so we'll have x into x minus 1.
Yes.
Plus 3 into x minus 1 is equals to 0.
Yes.
So we are having two factors, x plus 1 and x minus 1 and x plus 3 is equals to 0.
Yes.
Yeah, so if you work out, you'll get your x is equals to positive 1 and the other x is negative 3.
And also another question, are you substituting the x into the gradient function or the equation of the curve?
No, you substitute the x into the equation of the curve so that you get the corresponding value of y. Iko sawa? Iko sawa? Jeff, you're okay? Aya, so this is what we have. Mtu amepotea anasema show working. So that's what you have. The working is not showing everything, but I have explained. So you have x squared plus 2x minus 3 is 0. Then here we are factorizing. You're getting you factorize and then solve for x. So you get x to be 1 and negative 3. Then this 1 you substitute back into the equation of the curve to get the corresponding value of y. You'll get a third. And -3, if you substitute back, you get 11. So the 2 points are 1,3 and -3,11. APPS, unmute yourself.
Can you use the quadratic formula?
To solve?
Yes.
Yeah, you can solve using any formula, quadratic, completing square, bora ni formula ya kusolve quadratic equation.
Oh.
So let's go to the next part of the question. We've gotten the turning points. Then the next part is to determine the nature of the turning points. How do we determine the nature of the turning points of a curve? Nature of the turning points of a curve? Yes, APPS. Unmute yourself.
You differentiate again that equation.
So we differentiate a second time.
Then you use the value, the x, those coordinates that you found. You replace x with -1 and -3. Then if it is above 0, it's a minimum point. And when it is below 0, it's a maximum point. And when it's a point of inflection.
Good. So we differentiate the second time. You get d squared y dx squared. So that is, you differentiate the gradient function again to get the second derivative. Then you substitute the values of x and then check. If the value is positive, it's a minimum. If the value is negative, it's a maximum. So the second derivative ndio hiyo hapo. D squared y dx squared is 2x plus 2. Remember, we are differentiated the first time tukapata dy dx. dy dx was x squared plus 2x minus 3. So now we are differentiating dy dx to get d squared y dx squared. So that will give us 2x plus 2. Then once you get 2x plus 2, you now take the x coordinate of each point, each of the turning points. So if we take the first point, the x coordinate was 1, you substitute into the second derivative. Someone has a question. Yes, Tula. Unmute yourself.
So about can you please repeat about the dy and dx?
So I've said we want to determine the nature. So we get the second derivative, d squared y dx squared. D squared y dx squared, you get it from dy dx. So ukisha differentiate ukapata dy dx, then now you differentiate dy dx to get d squared y dx squared. Sasa tukidifferentiate hii dy dx, we are getting 2x plus 2. Iko sawa? So after getting the squared y dx, sasa tuna substitute. You take the x coordinates of each point, each of the turning points. So like the first one, the x coordinate was 1. Hiyo 1 una substitute kwa your second derivative. So it will be 2 times 1 plus 2. We are getting 4. 4 is a positive value greater than 0. So if the value is positive, then that point is a minimum point. Then again, we go to the second one, -3. You substitute into the second derivative. So if we substitute, it will be -6 plus 2, which will give us -4, a negative value. So a negative value shows that this point is a maximum. So the natures, the first one is a minimum, the second is a maximum. Any question? Yes, John. Yes, John?
Sorry, but could you kindly repeat?
Which part? They say how to get the second derivative.
how to tell if it's minimum or maximum?
Okay, so I've said to tell, first of all, you get the second derivative, which we get from dy dx. Ulikuwa umeshapata dy dx. So from dy dx, you get d squared y dx squared. Hapo umeelewa? Yeah, so now we have 2x plus 2. Then we had gotten the coordinates of the two turning points.
Yes.
The first one is 1 comma third. So here 1 comma third, you take the coordinate, the x coordinate, which is 1.
Yes.
Substitute into this second derivative. So it will be 2 times 1 plus 2.
4.
Unapata 4.
Yes.
Then now this 4, hii 4 si y, huyu mtu ameandika 2y. It is not y, it is the second derivative. Evaluated at x is equals to 1. So we are getting 4. So when if you get 4, you look at the value that you get. If it's a positive value, kama ni positive, then it means the point is a minimum.
Oh.
Positive is a minimum point.
So positive is minimum, negative is maximum.
Is maximum.
That's all. Thank you.
Aya. Any other question? Okay, so now we have determined the nature of the turning points. Then we go to sketch the curve. The next part is you sketch the curve. So before you sketch a curve, what are some of the things you're supposed to consider? Before you sketch a curve, you consider what? Yes? Any ideas? Before you sketch a curve, what are some of the things you consider? You're not responding. Before we sketch a curve, what do we consider? Yes, APPS.
X and Y intercepts.
Good. You're supposed to know the X and the Y intercepts. What else? What else are we supposed to know before sketching a curve? The X and the Y intercepts, yes. Wanje, you can unmute yourself.
The turning points.
The turning points, good. And their nature. So you know the x-intercept, the y-intercept, the turning points, and their nature. Then now we can sketch. So we already know the turning points and their nature. Let's find the x and the y-intercept of the curve. What is the x-intercept? Yes, APPS.
Y-intercept is 2.
Y-intercept is 2.
Yes.
The y-intercept is 2. What is the x-intercept? What is the x-intercept? So sometimes a curve might not have the x-intercept, kama ikati the x-axis. But if it is cutting through the x-axis, it must have the x-intercept. Yes? 0, what is the x-intercept? What is the x-intercept? We can work it out. Tunatafuta. So x-intercept occurs when y is 0. So weka y is 0, and then utafute the values of x. Somebody mwenye ameinua mkono, sioni jina. Unmute yourself. So, you know how we get the x-intercept when y is 0. So utaweka to 0 is equals to a third x cubed plus x squared minus 3x plus 2. Then you're supposed to solve to get, you're supposed to solve it to get what? To get the value of the 3 values of x. Utaweza kusolve? So to solve it, normally we start by finding a value of x. So I'll just try and take you through. Ikikataa kueleweka, tutaelewa baadaye. So just try out what kenye na explain. Make sure uko na kalamu na karatasi. So we are solving that it's a cubic equation. So if you are given a cubic equation to solve, the first thing is to find you find a value of x that if you substitute in that equation will give you 0. Hiyo value una try to, you start from 1, -1 or +1, +2 or -2. So let's find the value of x that if you substitute into that equation itatupea 0. Ni gani? If x is 1, try +1. If x is 1, what we get? Mnajaribu kweli? Are you there? You people are not responding. Sasa sijui kama tuko pamoja ama tumepotea. Okay, so let's just do with the x, the y-intercept and the turning points. Miles, your hand is up. Miles pia amepotea. Okay, so I'll just explain how to sketch the curve. Wanjei anasema haelewi. Amepotea. So I was saying, normally you're supposed to find the x-intercept and the y-intercept and then the turning points and their nature. So for this one, we have found the y-intercept. But now for the x-intercept, you have to solve a cubic equation. So your cubic equation, I was trying to explain how we solve it, and you people are not responding. Hugo, unmute yourself. Unmute yourself. Hugo amepotea. Unmute yourself, yes.
As you've said,
Yes. Yes, I can hear you.
when we replace the
Unmute yourself.
as you've said, when we put or we replace rather x with 1, we get a third.
Yeah, so if you get a third, unaenda namba ingine because we are looking for a value that if we substitute, we have to get 0. Are you together? So ukipata kama ni a third, unaenda the next one. -1, you try -1. You try 2, +2, +2, -2, +3, -3. Hivyo, hadi upate a value that if you substitute there, will give us a 0. Nani amepata value? Hugo, you can unmute yourself. Nani amepata value that if you substitute there, will give us a 0? So to make it easier, we have done +1 is not working. Someone to try -1, mwingine +2, mwingine -2, +3 and -3. Try those ones. We're just substituting. So someone to work out when x is -1, kama ita work out, mwingine ajaribu +2, mwingine -2, like that. Ukipata mwenye atapata 0 utuambie. Kama ipatikani tuendelee. But I'm sure it's there because it seems the curve must cut the x-axis. Sometimes you don't get the value if the curve is not cutting the x-axis. So nani amepata positive 3? Negative 3 itakuwa nini? That will be negative 27 over 3 plus 9 minus 9 plus 2. Nani amepata value? If you're not getting the value, you can try it later because of time. So, or you can leave it. Kirudi shule, you can consult. Because it's a long process, I was supposed to explain the whole of it. Tukishapata hiyo value ya x. Nani amepata? Any value of x that gives us a 0? Yes, Adrian. Adrian, I've said just look for a value of x that if you substitute in the equation, will give you 0.
So the y is supposed to be 0.
Yeah, at x-intercept y is 0. So tunaweka y ni 0. Then this other side is a cubic equation. You can't solve unless you get a value of x that will give us a 0.
When y is 0.
Yeah, no, si tumeshaweka y ni 0. So equation imekuwa a third x cubed plus x squared minus 3x plus 2 is equals to 0.
Yes.
Ndiyo. Yeah,
Yes.
so sasa tunataka kusolve hii cubic equation. So for cubic equations, the first step inakuanga utafute a value of x yenye ukisubstitute kwa hiyo equation utapata 0. Hiyo ndio tunajaribu kutafuta hiyo x na bado hatujapata.
Sawa.
Nani amepata? Okay, kama haijapatikana, we can work it out later on. Or if you come back to school, you can consult. So now for the sketching, ukishapata the turning points, umepata the x-intercept and the y-intercepts, then you plot the turning point, una plot the x-intercept and the y-intercept. Then the rest you just sketch. And there's someone ameinua mkono. Ebu unmute yourself. Sioni jina. Infinity. Ebu unmute yourself. Okay, as we wait for him to unmute himself. So this is the sketch. So hizi parts zenye zimecross the x-axis. Huyu pia hakutafuta. But you're supposed to get the value so that you know where exactly it cuts the x-axis. So for the y-intercept, ameweka, it is there. We got 2. Sammy, just a minute. I will ask you to unmute yourself. So for the y-intercept, tuko na 2. Then you plot the 2 turning points. And usually, you write their coordinates there. We hajaandika, but when you are plotting the turning points, juu ya hiyo point unaweka the coordinates in bracket. So when someone is looking at your sketch, I'm supposed to see your y-intercept, your x-intercepts, and then the turning points with their coordinates. Zimeandikwa hapo. Then of course the minimum and the maximum. So from the nature, tunajua gani ndio maxima na gani ndio minima. And then of course you write the equation of the curve. Sammy, you had a question. You can raise up your hand again nikuulize uji-unmute. Sammy, you had a question? Okay, Sammy amepotea. So that's how the sketch looks like. But sasa hii hapa, you have to state the easy values, the x-intercepts. So at your own free time, just try and find out the 3 values. Okay, not the 3 values. The value of x that will give you a 0. Then ukishapata, it is a long process. Anyway, ukirudi shule, you can consult. Kama tungepata, I would have taken you through. Nani amepata? Any value that if you substitute there will give us a 0. Hakuna, so tusipoteze hapo wakati. You can try it later on. Ukipata hiyo value ya x, then from there I will show you when you go back to school, or you can ask anyone, any teacher that you'll find there. Any question? Nani ako na swali? You people are not talking. Are we still there? Yes, Brian? Unmute yourself, Brian.
Nilikuwa nauliza hapa kwa hii ya nini, kuna hii ya turning point ya 1 and a third.
Yeah.
Mbona hii value imekuja kwa hii nini, hii curve imekuja nini on the negative side, na y kwa nini, kwa hiyo kwa y nasema third, sielewi.
Yetu ilikuwa, hebu turning points zilikuwa 1, third and -3, 11. Oh, so hii ya third inafaa kuwa huku juu.
Yeah.
Inafaa ikuwe juu. So kama iko juu, then it means our curve is not cutting the x-axis. Maybe that's why we are unable to find the value of x that will give us a 0. Haitaenda kwa x-axis. So from 2, itakuwa hapa juu. 1 and positive a third, somewhere on top of the x-axis.
Okay.
Yeah. Maybe that's why we are unable to get a value of x that gives us a 0. So not all curves to the x-axis. Welcome. Any other question? Nani mwingine ana swali? Okay, so for the curves, make sure hapo kwa turning points lazima uweke coordinates. Huyu mwenye alitengeza hakuweka. So put the coordinates of the turning points. And then ucorrect inapita juu sio chini. Any other question? Okay, no question. So let's go to the next question. The next one in your graph. So hii graph, anyone with a question kwa graph? Hizi za form 2, reflection, enlargement, whatever. Hizi za form 2. Kuna swali? Any question? Naweza nikaipita, we go to the next one because of time. Anyone with an issue with the transformations in form 2? Yes, we have someone. Na amepotea tena. Sibao, you had raised up your hand. Okay, anyone else? Anyone else? So tunaweza ipita hiyo. Yes, Elvis. Mbona mnainua mkono alafu mnapotea? Elvis pia amepotea. Any question? Okay, let's go to the Smiles. Smiles, you have a question? Miles ametoroka. Kwani mnainua mkono na mnatoroka kwa nini? Any question or I go to the next one? Okay, someone is saying tupitie enlargement. Yes, Wanje, you have a question? Unmute yourself. Okay, Wanje pia amepotea. So mtu amesema tupitie enlargement. So enlargement, basically what you're supposed to know there is enlargement kuna mara tatu, the 3 things. Kuna when the scale factor is positive, when the scale factor is negative, and when the scale factor is a fraction. So when the scale factor is positive, when the scale factor that is a positive whole number, positive, negative whole number, and then we have fractions. So for the fractions, whether positive or negative. So if you have a positive scale factor, then you are given the points. So if you have a positive scale factor and you're given John Chris, unmute yourself. Okay, so tunapitia enlargement. So enlargement unafaa kujua how to get the image given the object and given the enlargement scale factor. So usually what you do, if you're given the enlargement scale factor and you're given the image, you just join each point of the image. So for example, you can join point A. If you're given point A, una join to the center, that is O. Of course, you have to know the center of enlargement. Then after joining, you measure the distance from O to A and then multiply by the scale factor. Multiply by the scale factor. Then when you, after multiplying by the scale factor, if for example, OA was 2 units, if you multiply by the scale factor to 3, you're going to get 6 units. Those 6 units you measure from the center. From the center. So if it is positive, you measure it from the center and then going towards the same side as the object. Going toward the same side as the object. Kama ni negative scale factor, you measure it from the center but going the opposite side of the object. Then you repeat that one for all the points and then you join. You repeat that for all the points and then you join them and get your image. So if the scale factor is more than 1, then you expect your image to be bigger than the object if it's not a fraction. If it's 1, it will be equal in size. Then if it is positive scale factor, the object and the image will be on the same side. That is, the object will be in between the image and the center of enlargement. If the scale factor is negative, then the object will be on the opposite side of the center of enlargement and the image will be inverted. Then for a fraction, of course, kama ni positive and negative, the process is the same, only that for the fraction you expect the object to be, if it is a proper fraction, you expect the image to be smaller than the object. Someone is saying we pardon. Hebu unmute yourself. Sijaisoma yote. Unmute yourself and ask. Nasema kindly pardon the, I think he's saying the scale factor part. So the scale factor nimesema if you're given a positive scale factor, then you just measure from the object to the center, then multiply that distance by the scale factor. Then ukishapata, if it's a positive scale factor, you measure the distance that you've gotten from the center going towards the same side as the object. Na kama ni negative, you measure from the center going towards the opposite side of the object. I hope hapo imeeleweka. So for enlargement, ni ujue tu the process of enlargement, how to enlarge. Ukishajua how to enlarge, then also you have to know how to get the what? The scale factor and maybe the center of enlargement. If suppose you're given the object and the image, you can be given the coordinates of the object and you can also be given the coordinates of the image. So ukipewa hizo, how do we get the center of enlargement and the scale factor of enlargement? Yes, Miles. Yeah, we are almost ending. Mtu ananikumbusha hapa time. Tunamaliza. Time imeshafika. So let me just finish with that. If you are given the object and also given the image, after plotting the object and the image, to get the center of enlargement, you join the image points to their corresponding, the object points to their corresponding images. Then they are going to meet at a certain point. That point will be your center of enlargement. Wanje, you can unmute yourself. Unmute yourself. Okay. Then once you get the center, you can also, Brian, you have a question.
Unaweza rudia hiyo part ya fraction.
Fraction, I've said if the scale factor is a fraction, kama ni proper fraction like a half, whether it is positive or negative, the process of enlargement is the same, but sasa kama ni fraction, the objects will be smaller than the image. So if it's a positive a half, for example, you still measure from A to O, the center, and then multiply the distance by a half. And then measure it from O towards the same side as A, kama ni positive. Kama ni negative a half, you measure it from O going towards the opposite side of A to get your A prime. So if you've done that for all the points, what I realize the image will be smaller than the object. Kama ni positive, the image will be in between the object and the center of enlargement. Kama ni negative, the image of course will be on the other side of the center, but itakuwa inverted. Huyu mtu sijui kama nikumbusha time. Unmute yourself. Tunamaliza. Do you have any other question? Okay, we can stop there. Then hatujamaliza paper. So this paper is in the wall, kwa wall ya class. You can get it there plus the marking scheme. And also remember to download the marking scheme of the other paper, the paper 2. So thank you for joining in. We can stop there. Wishing you all the best as you prepare for your exams. Wanje, do you have a question? Unmute yourself and ask. Wanje, unmute yourself. Aya. So we are stopping there. Mkono iko juu, but you're not unmuting yourself.